This is Honors Geometry Lesson 10.4, Inscribed Angles, Part 2. So in Part 1, we talked about an inscribed angle. We said an inscribed angle is made up of two chords that share a common endpoint. That endpoint's on the circle, and it's the vertex of our inscribed angle. And we said the secret is, whatever the measure of the arc is, the inscribed angle is half of that. So we're going to use that rule to come up with a couple more rules. First one says if two inscribed angles of a circle intercept the same arc, then the angles are congruent. So let's take a look at that. Here's our intercepted arc, AB. So big to little, we know we're going to cut that in half. Let's say that's just 100 degrees. And so if we go all the way to the other side, you could see angle C is going to be 50 degrees. But if you look at angle D also uses that 100-degree arc. So big to little, you can see angle D is also 50 degrees. So that's what they're saying. If two inscribed angles use the same arc, then those two angles are going to be congruent. Sometimes that's hard to see. The next rule we're going to use from our inscribed angle rule is that if you have an angle inscribed in a semicircle, you can assume that angle is a 90-degree angle. You can see this is the diameter, so we can assume that it's a semicircle. It's 180 degrees, big to little, so we know that angle B is 90 degrees. The last one says if you have a quadrilateral inscribed in a circle, then opposite angles are supplementary. And again, that comes from our inscribed angle rule. So if you look at angle A's intercepted arc is right here. If you look at angle C's intercepted arc starts at B and goes all the way to D. So you see between angle A and angle C that they use the whole circle. They use 360 degrees. And you know we cut that in half, so we're going to divide by 2 so that you can see that between angle A and angle C we must have 180 degrees. So the rule is opposite angles in an inscribed quadrilateral are supplementary. Let's go ahead and practice. First one uses the fact that we have an angle inscribed in a semicircle. The endpoints are the diameter. So I'm going to go ahead and automatically assume that that angle C is a 90-degree angle. We know all triangles have 180. So if we take 90 plus 55, and we subtract that from 180, you can see that our missing angle is 35 degrees. The second one is using the rule that says if two angles use the same intercepted arc. So here's angle M, and its intercepted arc is from L to N. And you can see that angle P also has that same arc. So if the angle is 55, we know that the arc is 110, big to little. We're going to cut that 110 in half and we're back to 55. So the answer is the measure of angle P is 55 degrees. And we're going to use that same rule. They both share the same intercepted arc. Here's this angle, and there's this angle. So you can see we don't know how big the arc is, but we know that these two angles are going to be congruent. So I'm going to go ahead and just set them equal to each other. So I'm going to say 6x minus 11 equals 3x plus 7. Subtract 3x from each side, add 11 to both sides, and divide each side by 3. So it looks like the value of x is 6. All right, one more. We're going to use the fact that opposite angles are supplementary. So I'm going to take 180 minus 165, or I'm sorry, minus 65. So that means this angle is 115. And we're going to take 180 minus 119. So I know that angle G is 61. All right. Now we're going to find the intercepted arc for the 65-degree angle. It creates this arc here. So I'm going to take 65, I'm going to double it. So I know that arc is 130 from V to G. Now I'm going to take this angle V, and its intercepted arc is from F to H. F, go through G, stop when you get to H. So I'm going to take that 119, and I'm going to double it. So I can see that from here all the way to here is 238 degrees. Now I'm going to take that 238. We're given that this section from G to H is 168, and then that should tell us my missing piece there. So I'm going to subtract 168, which was given. And it looks like this missing piece here is 70. So now we know that this whole thing was 130. So if we take 130 minus 70, we can see that question mark, which is what we were going for, equals 60 degrees. Okay, let's try a few more. Okay, here it is. Opposite angles are supplementary. So we know this would be 100. And we know this would be 85. Threw a little algebra in there, it's fine. If this is 60, we know this is 120. Divide by 2, so it's a 0. It looks like K is going to be 60. Opposite angles are supplementary, so we know M is going to be 120. All right, here's another tricky one. First thing I maybe will do is find this missing arc. I know a whole circle is 360. So I'm going to take 360 minus 54 minus 110 and minus 130. So it looks like our missing piece up here is going to be 66 degrees. Okay, so now for B, you can see B uses this arc. It's the intercepted arc. It's 110 plus 66, or 176. And big to little, we're going to cut that in half. 176 divided by 2 gives us 88. So I know that angle is 88. Divide by 4. It looks like the value of B is going to be 22. Now for A is this angle. So that means it uses this arc. So I'm going to add the 54 plus the 66. Get 120. Big to little, we're going to cut that in half. That's going to give us 60. So I now know that 3A equals 60. Divide by 3. It looks like A is going to be 20. Okay. Please try the practice problems. Let me know if you have any questions. Thank you.